Myself, Dr. Shalini Hanok, Associate Professor, Department of Electronics and Communication Engineering, ATME College of Engineering, Mysore. Here, I am here to explain the program number 4. Previously, I had explained the introduction to Keel software, and my colleague has explained the other programs. So, I'll be explaining the program number 4. So, let me explain the logic behind it. So the program number 4 according to BEC 456 is, the program states that write an ALP to exchange the source block starting with address 10H internal memory containing N, that is 6 bytes of data, with destination block starting at location 2000 external memory. So we are exchanging the blocks of internal memory location data with an external memory location 2000H. That's the program about. And this is the program which is written, and we can write in a different multiple ways the programs, and this is the logic I have followed here. So we have an origin given, then we have this initial count. So how many data blocks we have to move? So we are moving 6 data blocks according to the statement given in the program. So we are initializing the counter at the register R2. Then we have to initialize the internal memory location, that is 10H is the memory location, internal memory location, which we are saving in the register R0. Then we are initializing the external memory location, that is external memory location as it is given in the question, that is 2000H, that we are initializing to DPTR. DPTR is the 16-bit data pointer register, which we can hold 16-bit data. That is the only register which we can hold 16-bit data. Rest registers which we are having in 8051 microcontroller are all 8-bit. So this is only registers we have 16 bits, so we are using DPTR. So we are moving this address, external address, memory location address to DPTR. Now we have to take the DPTR data, the data is present in DPTR, that is 2000 data, and put it on to, we are using the accumulator as a temporary register to store the data, and finally after that we are going to put it in the address 10H. So this statement move x a comma at the rate of DPTR means that, since we are getting the data from external memory location, we will be using the opcode move x. So move x at the rate of DPTR means, so here before execution this is how the data looks like. So in here it is 10, so it will be 10, 11, so by mistake it is, so it is 10, 11, 12, 13, 14. These are the different memory locations we are having, and in the different memory location the data present is 12, 24, 56, FF, EE. So these are the different datas which are present in the internal memory location, and this is the external memory location. In external memory location we are giving the data 0A, 0B, 0C, 1 and 2. This is the external memory location. So finally after execution this entire data will be moved to this memory location, internal memory locations. Here 0A, B, OC, 0C, 01, 02 is moved to this memory location, and the data which is present here 12, 24, 56, FF, EE will be moved to external memory location. This is the results we have to acquire. So for this what we are doing here is, we are copying the data which is present at DPTR. At the DPTR will be pointing to 2000 memory location. So now the data 0A has been copied into the register A. So after that we are using move B comma at the rate of R0, because at the rate of R0 is the 8-bit memory location, that is internal memory location. That's the reason we won't be writing move X, we'll be writing move. So here we can change it to 20. So here, so the 20 memory location from this, in the 20 memory location the data is 12. So 12 will be moved to B. So it will be moved with B. So B will be having the data 12. Now A is having the data 0A and B is having the data 12. So after this we are going to use the instruction exchange A comma B. So wherein B is having the data 12 and A is having the data 0A, when the exchange instruction is executed, A will be having the data 12 and B will be having the data 0A. So now the registers, inside the registers the data have been exchanged. Now we have to copy it into the respective addresses. So what we are doing here is we are going to move this particular A data to the DPTR. DPTR will be pointing to 2000. Inside the DPTR we are moving the data um, 12, so which is the memory location, internal memory location. So now when A is moved to DPTR, that particular 12 is moved to DPTR, and B is having 0A, that 0A is moved to 20 memory location. So now one data has been exchanged between from 12 and 0A, it has been exchanged 0 and 12. Now this particular steps has to be repeated for all 5 datas. Now one is being moved, now for all 5 it has to be repeated. That's the reason we are going to increment the register R0 is been is holding the internal memory location address that is been incremented. Now the internal memory location will be pointing to 21, that is the data will be 24. Then increment DPTR, we will be incrementing 2000 to 2001. So after this we are going to use the statement. The statement means decrement R0 and jump on no 0 to the label back. So it decrements R2. R2 is having the counter value 6 as we have initialized here. So once it is decremented, now from 6 it will be 5. So it will move to the label here. So it will repeat all these steps again for the second data. So similarly it will be repeating for third, fourth, fifth, and finally all 6 datas have been moved here to internal memory location, and from this internal memory location data is moved to external memory location. This is the logic of the code. Now we will see how this will be executed in Keil software. So let me open the Keil software. Let me open a new project which is on desktop. So the program that we will be writing is program number 4. Open the folder and we can say this as program 4. This is the file name which we have given. Now as usual we have to select the microcontroller. So we are supposed to select 89C51 ED2. Okay. Yes. So now target has been created for the project. So we have startup. So we can expand this now. Now we have to write the program. Go to file, new. So now we have to type in the program here. So since I already have the program, so I'll be just copying this and pasting it here. So but students are asked to type the program. So let me remove all these comments here. Okay. Let me align it properly so it looks good. Since the memory location we are transferring from 20H, I'll just mention that. Now the program is all set to be built. Okay, now the very important thing, we have to add our project here, our assembly language programming. We have to save and add it. So go to file, save as, and yeah, we have program 4, so we have to save in this particular folder, prog4.asm. Now the color has been changed. Now we have to add that to the source group. Go to add existing files. So we have this our program here. If we can't see, then go to all files, we can see, or you go to ASM file, you can see our program. So go to our program and add it. Now the program has been added. So we are supposed to have all these files in the project window, or else it won't run. So we have startup.a51 and prog4.asm. So that should be done. So now we will remove the unwanted spaces which are present or unnecessary. It will give an error. Yeah, we are using short jump to properly exit the program and then end it. Okay, now it's ready for building, so we are going to build. Now there is a zero error, zero warning, so there is no error since our syntaxes are right. So now we are moving the data present in 20H to the 2000H and from 2000H to 20H. Now go for debug and start debugging the session. Okay, it will be, now we have gone to the debug session, so now we have to open this memory window now. So these are the register files, and once we start debugging, before we start running the program, we have to locate, save our data. Go for d:0x20. So these are the different memory location. We are going to save the data there. Near 20, I'm going to save 12, 33, a different data, any data. So it should be 6 data, that's all. Even though you say 7, it will not take it. So it is 12, 33, 44, 55, 66, 77 is the 6 data we have fed into 20 memory location. Now we will do, for the ease, we are going to view another memory location so that we can easily view it, that's all. So in this different memory location, we are going to give external memory x colon 0x2000, enter. So now we have this at this particular memory location. We will give different datas a b b. Just give different data so that you can distinguish. A e f f. That's it. Now we will check how the data will be exchanged. Now we have fed the data inside different memory location. This will be exchanged. Go for stepwise running so that we can see the data exchange. So now we can see here R2 is having the counter value set, R0 is having the source memory location 20H, and DPTR has been set to memory location 2000. Now A is having the data AA, which is there in 2000 memory location, and B is being moved to with the memory location 20 data, that is 12. Okay. Now we can observe This 20 memory location has moved with AA data, and 2000 memory location has been moved with 12 data. It has been exchanged. Now only one memory location has been exchanged. We have to exchange the entire 5 memory locations. So you go on executing it, and we can see the movement between the registers, different memory location. We have different data. Now AA has been exchanged. Now we have the second data being exchanged. We can also skip this and go for overall run, and we can see this is stepwise running. I'll show you 3 data, then we can see the overall run. Now 3 data has been exchanged. Now we will see overall run. Now if we run overall, now you can see the entire 6 data have been exchanged here. Yeah, this is about program 4, wherein we are exchanging between external memory location and internal memory location. Thank you.